I think that's a quorum. So I'm saying that if events are mutually exclusive, the happening of event A will not deter the happening of event B. So we are talking of either A or B happening. Whenever we have two events that are mutually exclusive, or one event is not preventing the other from happening, we normally use a union. So this sign is a union. Or, we use or. So you can see the sign for independent. You can see the sign for a union. This is and, this is or, right? So when we are talking of or, it's either we are going to get the first one or the second one. So whereas here we are talking of the product, here we are talking of the sum, because the events are mutually exclusive. For example, rolling 1 or 2 on a 6-sided die. You know a dice. You know a dice. The cube that has one side 1 dot, second side 2 dots, all the way to 6 dots. Now, if I roll that dice and I wanted to get either 1 or 2, the chances of getting 1 or 2, the chance of getting either a 1 is 1/6, because it is a 6-sided cube. So chances of getting the 1 will be 1/6. Chances of getting a 2 is 1/6. Chances of getting a 3 is 1/6. In other words, if I do it for the first time, it does not dictate what I will get at the second tossing. I can get the 1 on the first toss, and when I toss it for the second time, I get a 1. Or I get a 2, or I miss all. You get? So we are talking of mutually exclusive event. The happening of one does not stop us from getting the results of the other. So those are mutually exclusive events. Then we have not mutually exclusive events. Now this will be now the opposite. But you can see, if the events are mutually exclusive, so we have the A or B. So you can see we are just adding the A and B and then subtracting. Because they are not mutually exclusive, we are now subtracting the chances of them being mutually exclusive. And chances are they are independent. So you can see it's like we are subtracting the independence. We said when it is A and B, we multiply. When it is A or B, we add. So for not mutually exclusive, for example, when you are drawing a single card, I don't know whether people here knows how to play the cards. A regular deck will normally have 52 cards. So the chances of getting a heart or a face card, either it will be a joker, a queen, or a king, or one that is both, will be 13/52, 12/52, or 3/52, because it is a set of 4/52. Are we there? Now, in the 52 cards or the deck of 13, or the 52 cards deck, 13 are hearts, 12 are face cards, and 3 are both. So the possibilities that 3 will be in the both will be included in either the 13 hearts or the 12 faces. But this should only be counted once. You get? So we are talking of a not mutually exclusive events. We are not doing it subsequently. We are only doing it once. So the chances of getting either a joker, a queen, or a king, and we are talking here of the hearts or the faces, will be 13/12, 13/52, the entire deck, or the 12/52, which are and now the hearts, or we are going to get the 3/52. Are we there? Then you have conditional probability. We are going to do so many examples until we'll normally use 3 things. Coins, we'll be using the dice, and we'll be using the cards. So these 3 we must get. If you don't know how cards are played, you can just Google and know the set of a regular card. Regular cards are used in the UK. I think US have an extra card, so they have a total of 56 instead of 52. So we'll be using the UK ones. So conditional probability. Conditional probability is the probability of some event A given the occurrence of some other events B. So the conditional probability is written as the probability of A happening given B. And it is read the probability of A given B. And you can see the probability of A given B. It is the probability of A and B over the probability of B. In other words, we are saying, if the probability of B not happening, then given A is formally undefined by the expression. So it is possible to define a conditional probability depending on what you want from the events or from the underlying event. That's the simplest that I can explain. Like, see, we've been given an example there. Let's say we have a bag. That bag has 2 red balls and it has 2 blue balls. So in total, we have 4 balls in the bag. So the probability of taking a red ball will be a half, isn't it? It is 2/4. 2/4 simplified is a half. However, if you take that ball and you don't return it in the bag, what will be the probability that when you go there, you are going to get a red ball? The remaining balls are 3. So given that condition that you picked red, the probability that you'll pick a red ball again will change to 1/3 because the balls that are remaining in the bag are 3. This is a conditional probability. You get? So we are talking of the probability of getting a red ball given blue. So if you take red and you don't return, the chances that you are going to take that red ball again decreases than when you are 4. Conditional probability. The other term, the over. I have the summary there. So we've said that the probability of an event, if I summarize, occurring will be between 0 and 1. And we normally talk of the success and failure. But when we talk of the success and failure, we are not talking, it's not the connotative or the dictionary meaning of success. For example, we can say the AFCON, African Confederation Cup, was won by penalties, isn't it? And we know Egypt lost to Senegal. Now, when we are talking of the success and failure in probability, it could be a negative event, but we talk of success. I'm trying to look for a good example of, so we are not talking of the dictionary meaning. In other words, we are talking of if chances are that an event will occur, that is a success. The chances that it will not occur will be a failure. So it's not the connotative meaning of success and fail. You get? So the success of that event means its failure will be 1 minus that event occurring. So if the success is 70%, then failure will be 1 minus 70%. So 70% is same as 0.7. We said your answer should be between 0 and 1. So 1 minus 0.7 will be 0.3. You get? So with those few remarks, I take you back to I think I've explained the terms that we'll be using interchangeably. I wasn't sharing the screen. Am I sharing the screen?
Yes, sir.
Okay. Let me now go to my notes. The notes that I was using. Well, let me now introduce the distribution. So when you are talking of the population distribution, we are talking of a display of a list of possible outcomes in an experiment. And the probability will be associated with, for example, we've been given an example there where we are flipping a coin 3 times. So if you flip that coin 3 times, the expected outcome will be, you can either get, we are going to have 8 possible outcomes. So you are either going to get head, head, head. You can get a head, and a tail. You can get a head, a tail, and a head. You can get a tail, a head, and a head. You can get a head, a tail, tail, head, tail, tail, head, or tail, tail. Now, if we summarize this information, chances that you are going to get 0 heads is when you are getting all the tails, isn't it? So you are getting all the tails once. So out of all the possible outcomes, which are 8, you are getting only 1 chance not to get any head, right? Then let us look at the chance of getting only 1 head. So we'll be going checking instances where we are getting a head only. So I have 1 head, I have 1 head, I have 1 head. So the chances are, if I flip that coin 8 times, and these 8 times are mutually exclusive, now we are using the terms. So the flipping of the second time does not dictate the outcome of the first. So the flipping of the subsequent coins will not, the outcome will not be dictated by what I got in the previous or the preceding flipping. So I'm going to get 3 out of 8 for 2 heads, and on and on and on and on. So I can get as many outcomes as possible. For instance, chances of getting a 0 tail will be getting 3 heads. Just giving an example. So we can list all the possible outcomes. Let me give another example. If we are flipping a dice, and a dice will have 6 faces, chances of getting a 0 is 1 over 8. Chances of getting 1 is 3 over 8. This is for probability. No, this is for the over. The dice should be giving us 1 over 6. This for the dice. So if we are, let's say, flipping now the dice, chances of getting a 1 is 1 over 6. The probability of getting a 2 is 1 over 6. If I flip it for the third time, the probability of getting a 3 is 1 over 6, all the way until I get the entire. Now, we have what we call either discrete or continuous, and I'll give an example. A discrete probability is where the outcome is usually a whole number. For example, let's say you are looking at the probability of a customer buying an item from a beauty shop. So what's the probability that they'll be either male or female? I want you to ignore transgender or the bisexual. So we are talking of what God created, male and female. Are we there? I don't have a problem with the other genders, But I want us for purposes of these examples. So you cannot get half male and half female, or you cannot get half a human being. You get, that is what we call discrete. So the outcome is as a result of counting, and it will be a whole number. For example, you cannot buy half a bread. Well, ukienda kwa kiosk za mashinani unaweza uziwa, but you cannot enter into a supermarket. You go to the shelf, useme ati ukatiwe mkate nusu. It never happens, isn't it? Or let's say you want to buy a bar soap. You cannot go into a supermarket and say that you need half. So we are talking of what is being taken as a whole or continuous. So whatever I've given here is an example of a continuous probability. So continuous is the one whose random variable can take any infinite number. Can be 0.001, can be 1/80, can be 50/1000, etc. But for the discrete, you go to get a whole number. Now, let me take you back to our first example. Now, when we are talking of the probability, in probability distribution, we normally talk of the expected value, and that is our mean. The expected value is our mean. For example, listing all the possible outcomes for the three, when you are flipping the coin 3 times, we've listed all the possible outcomes here. Now, to sum up all these outcomes, I'm going to get 8/8. In other words, probability should total to 1. So the probability that a random variable x can take one specific value is written as this. So this is the probability. For example, the probability that we are going to get 2 heads is written this way. And that probability of getting 2 heads, if I go back to our table, the probability is 3/8. So I'll say my P, or the probability of getting x is equals to 2, is 3/8. So the expected outcome is what we are calling the probability. So the probability that we are going to get 2 heads will be written this way. Now, a distribution in which probability of all outcomes are the same. For example, the tossing of the dice. We call that uniform probability distribution. So if we toss a die, we are expecting that we are going to get 1/6, 1/6, 1/6, 1/6, right? So in other words, our expected value, or what we call EX, the expected value is written as EX, where our X is either 1 or 2 or 3 or 4 or 5 or 6, will be 1/6. Is it clear? I'm still explaining the terms. So when we were talking of the population and the sampling, we were talking of the population taking the parameter when we are doing the census. But when we come now to the probability distribution, our mean is called expected value. So whatever the outcome that you are expecting, that becomes our mean. I think I've explained the discrete and the continuous very well. This is what I'm trying to explain. So the mean of the probability, we talk of the expected value. So we are talking of the expected value of the random variable. Remember, probability is the measure of the likeliness that that event will occur or not occur. Now we have so many approaches to this, but we'll be restricted to what we call the binomial distribution and Poisson distribution. At this level, we are going to take binomial distribution and Poisson distribution. So the mean of a probability distribution is referred to as expected value, and we normally write it as EX. These are the important points that you should be jotting in your books. The mean of probability is called expected value, and it is indicated as EX. There is no question that you will get outside the expectation. So when we are talking of the mean, it is that sum of the product of each possible outcome and its probability. For example, let me take you back to when you were tossing the coin for 3 times. Our outcome, we were able to get the, let me take you back. Don't get. So these are the outcomes. If we need heads and heads only, chances are we are going to get a 0 head. So the probability of getting a 0 head, the expected value is 0. And the probability is 1/8. The chance of getting the head once is 3/8. So chances of getting, or the expected outcome of getting only 1 head, will be 1 multiplied by 3/8. The chance that I'm going to get 2 heads will be 2. 2 heads will be 3/8. So my expected outcome will be the outcome, which is 2. I multiply by the probability, which is 3/8. The chances that I'm going to get 3 heads is 1/8. Now, if you add these together, you're going to get a whole number, which is 1. That's why you say that probability is equal to 1. So our expected outcome should total to 1. But when we are talking of now the probability, we are going to get the product. That's why we are multiplying. So 0 multiplied by 1/8, 3, 1 multiplied by 3/8. Then you have 2 multiplied by 3/8, and 3 multiplied by 1/8. So this is the outcome. So you can see the mean, or if I was to get now the expected value after tossing my coin 3 times, and those events are mutually exclusive. So I'm going to get the product. So I'm getting the outcome, I multiply by the probability. So in other words, the expected value is equal to the outcome you multiply by probability. So chances of getting a 0 head was 1/8. So the expected outcome was 0. I multiply by 1/8. The expected outcome of getting only 1 head was 3/8. So the expected outcome is 1. I multiply by 3/8. If I sum these together, and that's why I'm talking of the summation. If I sum all these probabilities together, I'm getting 12/8. Are we there? So you can see the expected value. Expected value is not probability, because someone can question and say, Mr. Mbugwe, you said probability must give us between 0 and 1. So our expected value will be 12/8. Are we there? So what will be the expected value of tossing a dice? I take you back to the table. Tossing a dice. This is the outcome. So our expected value will be 1 multiplied by 1/6 plus 2 multiplied by 1/6 plus 3 multiplied by 1/6 plus 4 multiplied by 1/6 plus 5 multiplied by 1/6 plus 6 multiplied by 1/6. That is the expected value. I go on. So I hope you've written the expected value is E into X. So our mean is E of X, which is the summation of all the outcomes multiplied by the probabilities. So this one will be giving you 3.5. Now that is the mean. For the variance, now remember we said that variance is standard deviation squared. It does not change. You can see our variance is standard deviation squared. But the way we do it in the probability distribution is what I want all of us to appreciate. So you can see what is happening. We are taking the outcome and we are deducting the mean. Now mean is what you got up here. And mean we've said is EX. So the expected outcome, I deduct from that outcome, that particular outcome. For example, when you are tossing the dice, which is nearer here, so it will be easier to compare. Look, for the first time, I'm getting my mean is 3.5, right? So what is happening? I'm squaring my standard deviation to avoid absolute. So you can see it is X, the outcome, minus the expected value squared. And then I multiply by probability that that event will occur. So variance is the mean of the squared deviation from the mean. So in that case, our expected value for tossing a die will give us, for the first time, our outcome was 1, isn't it? So 1 minus our mean, or the expected value, which is 3.5, we square that, we multiply by the probability. So we are applying the formula in totality. So 1 minus my outcome, or the expected value, multiply by the probability. So this is the formula. So again, I want you to have that. I normally tell students not to adopt the second one because you'll be confused, especially for the complex probabilities where they are independent, and then at some point you are given a condition. It becomes a bit hard to apply the second formula. So for now, let us use this. Of course, after a lot of practicing, you're going to adopt this. But I normally use this when we come to business statistics too, for complex probability distributions. So I'm waiting for you to absorb the formula. Have you? And you've written it somewhere. I'll share these notes. I'll also share the recordings. So the first one is binomial distribution. And you can read ahead. I want to introduce binomial and Poisson in our next class. What I'll do, I'll give you examination type of questions in the portal for your practicing, so that you can be able now to try and get the standard deviation. You can be able to get the variance of the ungrouped and the grouped data. Then I'll now come to the probability. I'll check the mean, whether you'll be able to get the expected value and whether you'll be able to get the variance. You said the approach is the same. Our variance is standard deviation squared, only that in the probability distribution, we are getting our outcome, we subtract from the expected value. Then we square. From there, we multiply by the probability of such an event occurring. Don't think that is too much to ask. I'll be posting let me give you like 3 questions in the portal. You try, and you try to respond in the course of this class. Any question? Any question? Don't log off. Let me take the let me take a screenshot because of the register. You're now at liberty. You can log off. Enjoy your weekend. Again, I reiterate, people should do a lot of practicing, because I've seen students also not performing so well in this particular unit. Kindly do a lot of practicing. Business statistics is so easy, can be so hard if you haven't practiced to perfect in the area. Enjoy your weekend. Mary Dega, you're on call.
Yes.
You're saying something? Or you are wishing me a good weekend? Emily Kibet?
Present, sir.
You've caught up with us.
Yes.
Enjoy your weekend.
Thank you.